We're now going to concentrate on spheres. We're going to be doing surface area and volume of a sphere. So all the stuff we've been doing before, we separated surface area out for cones and pyramids, and we kept those together, and we did surface area last week. We did a little bit of volume this week, or all the volume this week. And now we're going to put these together with spheres. We took spheres totally out because they're nothing like what we've seen before. They have no flat sides at all. They're all round, all around. All around, all around. But this is the sixth section of the 11th unit. Let's get started. All right, here's a sphere. You need some vocabulary before you start. You ready? You need to know that a sphere, everyone look up here, you guys are doing stuff. A sphere is a point, are points in space that are equidistant from a given point. The given point is in the very, very center of it, and everything out equidistant from that. It's like if I right here held a rope, and I held it right here, and then if somebody held the end of that rope, every point all around it, at the end of it, if you could have a little marker on the outside of it, it would color a sphere all the way around. You understand what I'm saying? What if I just went like this, and I had a rope, and I just walked in a circle, like I walked around. And I put a marker out here. What shape would this make?
Circle.
It would make a circle because that's in a plane. But if I did it all around, it would be a sphere then. In space, they're equidistant from a given point. On that sphere, or with that sphere, we have some other vocabulary. We have the center, and that is that given point that was at the end. And then we also have a radius.
That's a cool picture.
Okay? And that's a segment that's from the center out to the sphere. And so here we go. Here's going to be, the center is going to be in the middle of that sphere, and then coming out. This is my radius. That's the center. Any questions so far? Surface area of a sphere. You have 4 pi r squared. That's what you've been memorizing for the last couple weeks.
Yes.
If we pretend that the Earth was a sphere, we could find the surface area if we knew that the radius was 3,963 miles. We ready?
Yeah. Mm-hmm.
All right. So if I just put that in there, I put 4 pi times 3,963, or for Amy, the 3,963, squared, we would get 62 approximately million pi miles squared. But if I didn't want the pi, because normally when we're measuring like things like real objects like Earths or planets, we don't want to have the pi in there. So we would multiply the pi out. This is 196 million miles. 97 and some extra. All right?
That's a lot.
That's pretty big. Square miles, by the way. This is something that I need everyone to watch up here, because this is not just numbers this time. If you cut a sphere or a globe into, if you cut it, you're going to get bunches of circles, okay? So if you, if I cut an orange open and I turn the orange like this, it's going to be circles, right? Okay?
Mm-hmm.
And so people who do geography have actually drawn on our map these circles. And these ones that are going this direction are longitudes, or the other ones are latitudes. If we cut them along there, we have circles, each of those. The largest circle is going to be where?
Equator.
At the equator,
Or
at the prime meridian, right? And so the great circle, we have the sphere can be split into many different circles. We already talked about that, right?
Well, what if the Earth
To find the largest circle, we must cut it through the center. So if I cut it at the top somewhere up here, I'm going to get a circle, but it won't be the largest one. If I want the largest one, it's got to go through the center, through that middle line.
So you got to cut it across the diameter.
It's got to cut it across the diameter, yes, through the center. Because I could cut it, through the diameter. Here we go. Volume of a sphere. We have the formula. This time we have a fraction, 4/3 pi r cubed. We've had a 4 in some of our equations. We've had a 1/3. Now we're going to mix it together. And notice that this is the only equation with a cubed in it. The only one with a cubed in it.
That's for the volume.
That's for the volume. So if we found the volume of a marble that had a radius of 1 centimeter, we'd put a 1 where in that formula? Where the r is, and the r, we wouldn't have to do anything to it. This r would just become 1. The 4 and the 3 and the pi would stay where they are.
Can the thirds and the 3 on the bottom cancel?
This cubed and that 3?
Yeah.
No, because this means r times r times r. And this means divide by 3. Okay?
I know.
All right.
I was
So this
hoping.
cubed of 1 is 1 times 1
Oh,
times
wait
1
a
just stays
minute.
1. And so it's just going to be 4/3 pi. If
I don't have a button to push 3 in my calculator.
Push 3.
You have the square
cubed,
root
I'll
of
show you where it is.
To the power.
Oh, wait.
All right. So 4/3 pi becomes 4.189 centimeters cubed. Let's do some examples from your pages. We're going to do numbers 1 and 5. Not in the middle, just 1 and 5. Let's get started. Number 1, this says find the surface area. It says leave your answer in terms of pi. Do you actually, when you guys are doing those, do you like to leave them as pi or do you like to have the pi
I
multiplied
like
out?
to leave them as pi because I don't have to do anything with that. I can just leave it
Yeah,
out
but
and
it
then
drives
just
me
write it
nuts
down.
because
And
then
it's
you have to worry
mostly a nice
about not
number.
It
pressing
is. It's a prettier number when you do it that way.
Okay, fine.
All right, so
Yeah,
the
there's no, like,
surface
fancy
area
numbers.
of a, what's the surface area of a
Ah,
sphere? Is that the 4/3 or just the 4?
4 pi
Okay.
r squared.
All right, so we got the 4, we have our pi, and our r is right up there. It gave us 11.2. What is that?
Divide that by 2.
You have to divide that by 2 because it's the diameter, right? So I'm going to put 11.2 divided by 2. So you don't have to do anything with that 4. And your 4, by the way, and your 2 will reduce.
Divided by 2. Oh, no, okay. Yeah. I was like, oh, wait, no, I did that.
I get like 22.4 pi.
Huh?
Did anybody else get that?
Wait, for what? I
The answer?
got
No.
125.46
Squared.
That's
My bad,
right.
my bad, my bad.
pi kilometer squared. Yeah.
My bad. That whole thing about.
I did it right. Cool.
So what'd you get? 125
125.44 kilometers squared.
pi.
Pi.
Wait
Pi.
a minute. Something's not right.
Squared or cubed? Which is it?
Squared.
Yes. Yes. Are we ready for number 5?
Can you?
Did I get the right answer?
I tried it. I hope I'm right. If I'm not,
Number 5. We're going to do the volume.
I'm just moderately ahead.
The volume is 4/3 pi r cubed. We only have to put the r in there this time. And r is how much?
9.
Don't forget to cube it, because I almost did last time. What about for not 5? What did we get for 5?
So
972.
972.
Pi.
Sorry, 972. Yeah.
And then units?
Inches.
Inches cubed.
All right. Thank you very much. All right. We have now come to an end to this section. You know the vocabulary associated with a sphere. You can find the surface area and volume of that sphere. It's time to say goodbye.